So integrated to chapter 4, day 4. We're going to do slightly more complicated examples of these. And again, hopefully we're all on the same page here, that we're simply taking something out of standard form, or as we said in chapter 1, written as a sum, and we're factoring it, and we're writing it in factored form, because if it's in factored form, we're able to get the x-intercepts. We can also tell the a that it opens up and it's normal, but we're going to discuss that all later. So for now, I'm going to sort of ignore that for a second. But again, that's just sort of where we're at and what we're doing. So I did want to talk through a slightly more complicated version. I know I talked through example 1 in a previous video, so I want to talk through example 2 right now. So the steps are the same. The first thing that we're going to do is recognize that our a is 4, our b is 18, our c is negative 10. And we're going to try and initially factor. Well, hopefully we recognize that 2 will go into these numbers evenly. So I'm going to take a 2 out. And if I take a 2 out, I'm going to get 2x squared, right? 4 divided by 2 is 2. 18 divided by 2 is 9. And 10 divided by 2 is 5. Obviously, that x squared stays, that x stays, and that stays a negative. Now, the reason that I did that is because it's going to be easier to put it on the diamond. And again, it is an important step that kids often try and skip step 1 and step 3. It's just kind of inconvenient, and they don't always happen, step 1s and step 3. So a lot of times kids just jump from 2 to 4, and then they get confused as to why things didn't work out the way they wanted them to. So I would encourage you, just really kind of have this form next to you and be real methodical and go step by step. Long story short is, now that we pulled the 2 out, this is going to be our A, this is going to be our B, and this is going to be our C. So technically, this is our real A, B, and C, but for the diamond's purposes, we're going to say our A is 2 and our C is negative 5, so A times C would be negative 10, and our B would be 9. And on the side, when we say AX, we'll say 2X. Now again, technically speaking, these are our real A, B's, and C's. This is just helping us figure out the diamond. It makes factoring easier. So again, we're going to have 2x on top. So now, how do I get a 10, a negative 10, and a 9? Well, 1 times negative 10 is negative 10, and 1 minus 10 is negative 9, so that wouldn't be it. So what if I reverse them? Negative 1 times 10 is negative 10. Negative 1 plus 10 is positive 9. That would make more sense. So you can see I have 2x over 10 and 2x minus 1. Now I want to simplify the fractions if possible. Well, 2 over 10, hopefully we see 2 goes into 2 once, and 2 goes into 10 5 times. So we'll use x plus x over 5 here, but this one doesn't simplify, so we'll just use 2x minus 1. When we rewrite, we're going to have y equals, don't forget this 2. This 2 is a real thing, and it's going to become more important either in chapter 5 or chapter 9. It's not going to be a huge deal in chapter 4, I won't lie to you, but it is going to be a bigger deal in chapter 5 or chapter 9. Long story short, we're going to use this x plus 5, the 1x plus 5, and we'll use our 2x minus 1. When we set these things up, again, x plus 5 equals 0. Obviously, we get negative 5, so we'll have negative 5, 0. And then over here, we'll have 2x minus 1 equals to 0. If I add 1 to both sides, 2x equals 1 divided by 2, x equals 1/2, and that would be 1/2, 0. So I would expect to see these as my intercepts. So let me set that up in Desmos to show you. Over here we have y equals 4x squared plus 18x minus 10. So I'm going to go ahead and put that in Desmos. And again, we expected to see negative 5, 0 and 1/2, 0 as our x-intercepts. So there's our negative 5, 0. There's our 1/2, 0. Those are our x-intercepts. A couple of things I want to point out. First of all, I want to point out, look how steep this thing looks. It looks very steep. So the question is, why is this so steep? And if we go back over here, what we're going to end up figuring out later is that this a term, this number out in front, the a being 4, it has something to do with how steep it is, and it's going to have something to do whether it opens up or down. Again, right now we're not worried about that, but it will be important later. I just want to kind of point out there that if you're looking at that graph and it looks a little bit unusual. The other thing I wanted to point out, let me get my other note sheet up. So the other thing I want to point out, I just want to, this note page again. So hopefully you guys are filling this out. So hopefully you know what a quadratic is. It's that equation. It's again, that equation can be written multiple ways. I wanted to show the sheet instead. It can be written as standard form. It can be written in factored form. Eventually we're going to learn a graphing form again later on. But just to make sure that's what we know what a quadratic is, it's that type of equation. Just like there's linear equations, there's quadratic equations. The other thing I wanted to point out is that we should know what a parabola is. It's that U shape. We should have a rough idea now of factored form versus standard form and how that works. Obviously, we said standard form is the sum, factored form is the product, going back to chapter 1 again. Factoring, we should know that means breaking math into littler pieces like ice cubes. So there's a couple different ways of factoring. One would be the initial factoring that we talked about in that 411 worksheet. The other way of factoring is using the diamond. Those are the two ways of factoring that we know right now. Again, hopefully you know that initial factoring that we talked about. And then, like I said, now we have this process of factoring. So at this point, we really have discussed everything on this note page. So hopefully you have a decent understanding of what these top things are. And if you don't, make sure that you guys have that conversation. But the bottom, we're just going to keep practicing a few times till we feel comfortable. So long story short, we did see what we expected to see. It did graph the way we expected it to graph. Again, now we have a little inkling at that when the A term is 4, we're expecting it to be steep, which is kind of interesting. And we still have our x-intercept. So let me go and set up the next problem. This problem, and let's see if we can figure out the x-intercepts here. So the first thing, again, I'm going to do some initial factoring. Hopefully you see I can pull a 4 out of here. I can pull out a 4 out of each of these. So at this point, we already are beginning to suspect that this thing might be steep. Remember last time we saw a 4, it was pretty steep. So we would maybe expect to see something like that again. All right, now we're going to set up our diamond. Again, our A, B, and C that we're going to use for the diamond are right here. So A times C is 1 times negative 12. Our B is going to be here, is going to be 1. And then on the side, we now have 1x. And you can see if we didn't initially factor, we'd have a 4x on the side. So it's making it a little bit easier for us. A 1 and a 12, I can't add or subtract 1 and 12 to get a 1. 2 and a 6, I can't add or subtract a 2 and a 6 to get a 1, but a 3 and a 4 I can. Now think about it. It needs to add to a positive, it would be negative. What if I did that, right? Negative 3 times 4 is negative 12. Negative 3 plus 4 is 1. That makes a lot of sense to me. So now I will see if I can simplify these. 1/3 and 1/4 I can't simplify, so I will just go with y equals, don't forget, actually I'm gonna give myself a little bit of room here. So I couldn't do step 3. So step 4, don't forget about this 4. This 4 is going to be important later. Like I said, it's okay, I guess, for chapter 4 if you forget it, but it's going to be really important later, so you don't want to forget it. All right, and then now I can just solve. X minus 3 is equal to 0. X plus 4 is equal to 0. So I'm going to get x equals 3. I'm going to get 3, 0. And x equals negative 4. So I'm going to get negative 4, 0. So if I graph this shape, here's what I'm expecting to see. Intercepts at 3, 0, and negative 4, 0, and I'm expecting it to be steep. So let's see what happens. I want to graph this again. So I have 4x squared plus 4x minus 48, but also this x minus 3x plus 4. So let's go ahead and take a look over here. So you can see this is what it graphs as. I expected it to go to negative 4, 0, and 3, 0, which it does. So let's see if I graph it like this. Uh-oh, we have a problem. So I want to point something out here. There's something missing, right? I have my negative 4, 0, and my 3, 0. That's true. Like I said, it doesn't really matter for this chapter that we didn't put this 4 in. You might recall, remember? We have this 4 out front. I didn't put that in there. I don't know if you guys noticed that. I didn't on purpose. And the reason why I didn't is I want you to see the x-intercepts are the same. And in chapter 4, that's all we're really focusing on the x-intercepts. But you can see it does make a different parabola. What happens if I put the 4 there? Not surprising, it makes the same parabola. So that's why I keep harping on the fact that don't forget this 4. Make sure you rewrite this 4 because it does change the problem later on if you don't do it. All right, let's go ahead and do another example here. We have y equals 6x squared plus x minus 12. So what we'll do here is we will go ahead and do the initial factoring. There's no number I can take out of 6, 1, and 12, so I can't do step 1. So I'll go straight to my diamond. A times C is negative 72, B is 1, and I'm going to put 6x on the side. Again, because it's AX on top, right? AX on top. Now, 1 and 72 isn't going to go to 1. 2 and 36 isn't going to go to 1. 3 and, 24, I think? They're not one away from each other. 5 doesn't work. 6 and 12, no. 7 doesn't go in. 8 and 9. All right, 8 and 9 might work. But the 9 better be positive, right? Negative 8 times 9 is negative 72. Negative 8 plus 9 is 1. So there we go. I'm going to get these numbers right here. Now I want to simplify these sides if I can. Well, what is 6/8 over negative 8? Hopefully we see 2 goes into each of these. So we're going to get 3x over negative 4. And I'm going to use this one. And what about 6x over 9? Well, hopefully we see 3 goes into both of these. So I'm going to get 2x over 3. So these are going to be the two equations I use, right? So this is y equals 3x minus 4 and 2x plus 3. Those are going to be my simplified factors. These are my factors. Now I'm going to go to my solutions, or my x-intercepts. I'm going to get 3x minus 4 equals 0. I'll add 4 to both sides. 3x is going to equal 4, or I'm going to get x equals 4 thirds, which is obviously, right, 1 1/3. 0 is one of my x-intercepts. Over here, 2x plus 3 is equal to 0. I'll subtract 3. I get 2x equals negative 3. Divide by 2. I get x equals, obviously, negative 1.5, right? So I would expect to see negative 1.5, 0. So let me go ahead and set this up, and let's see if we actually hit those x-intercepts in Desmos. Equation, 6x plus x minus 12, and you can see our intercepts of negative 1.5 and positive 1 1/3 did indeed work, like we were hoping to see. So let's go ahead and set up the last problem. All right, so the last one, we're going to get y equals 6x squared plus 22x minus 8. It definitely looks like 2 will go into each of these, right? So that initial factoring is super important. Let's not forget about it. Also, let's not forget about the importance of that 2. Again, for this chapter, not a huge deal, but later chapters it will. 2 times 3x, 2 times 11x, 2 times negative 4. I will go ahead and I will set up my diamond. A times C, B. On the sides, I have AX. And now how do I multiply to 12 and add to 11? It looks maybe something like this. Negative 1 times 12 is negative 12. Negative 1 plus 12 is positive 11. So there we go. I'm going to try and simplify these fractions. You can see 3x over negative 1 doesn't simplify. So that, don't forget this 2, like I said, is going to be 3x minus 1. But this one does simplify, right? 3x over 12. 3 goes into 3 once, and 3 goes into 12 4 times. So that one does simplify. If I want my x-intercepts, I will say 3x minus 1 equals 0. I'll add 1 to both sides. 3x equals 1, so x equals 1/3. So I have y equals 2 times... actually, I'm rewriting it. I don't mean to do that. I'm sorry. What I want to do is put my 1/3 0. And then here, x plus 4 equals 0. Obviously, this one's an easier solution. So I will end up with negative 4, 0. So when I graph this equation, or if I graph this equation, I expect these will look the same, and I expect they will have these x-intercepts. So let me go ahead and set that up and see if that's true. You can see we have 6x squared plus 22x minus 8, and 3x minus 1, x plus 4. Our intercepts are negative 4, 0, and 1/3 0 like we expected to see. It's the same parabola twice. You can see with that a of 6 that it is pretty steep, and that opens up. I just want to throw this out here for the future. What happens if it's negative? Look at that, it opens down. So if that a is positive, it's going to open up, but if that a is negative, it's going to open down. So kind of an interesting change there. Another thing I wanted to point out, let's say it's flat. What if instead of 6 it was 1/6? So you can see, actually, I didn't do what I wanted it to. I think some of these other numbers are screwing that up. But anyway, it does actually make it flatter. I don't know, that didn't show it very well. What if I make this one a 4th instead of 1? So you can see the 1 is steeper, but a 4th makes it flatter. So anyway, that's something we'll be discussing more later.